All right, today I'm going to introduce you to limits. Now, I got to give you a little bit of a heads up. If I start saying things like, thank you for the ice cream, or please take that away, I'm not talking to you, I'm talking to my daughters, because I'm hanging out with my daughters right now. So, anyway, we're going to do the introduction to limits. So, first, let's consider this function, f of x equals x squared. Now, we've done a little bit with limits before. Now, when we did limits before, we just kind of said, okay, what was happening as x approaches infinity? And we talked through this idea of, for example, if I want to find the limit as x approaches, let's say, 2 of f of x, so then we would say, okay, well, let's find the limit as x approaches 2 of x squared. Now, by definition, the way that you should do this is you should put in various x values and then get out various f of x values. And so we'll start a distance away from 2, and we'll get closer and closer to 2. Now, if we do that from the left-hand side, so that would be a little bit less than 2, maybe I'll start at 1.9. And so I'll put 1.9 in, and I'll go 1.9 x squared. So I'll go 1.9 squared, which is 3.61. And then I'll go 1.99, which is going to get a little bit closer to 2. So now I'll go 1.99 squared. All right, and I got 3.9601. And then I'll go 1.999 squared. All right, and so that's the idea behind the limit, is that we'll just keep getting closer and closer, 3.996 now. Okay, now we're going to do it from the left side, and we're going to do it from the right side. All right, so on the right side, we're going to start at maybe 2.1. And so I'll go 2.1 squared, which is 4.41. And then we'll go 2.01. And so we'll go 2.0, because I'm getting a little bit closer to 2 there, so 4.0401. And then we'll go 2.001, so getting even closer to 2 from the right side, because we're looking at x values, so 2.001, so 4.004. So you can tell we're getting closer and closer to 4 right here in the middle. Now, you can see that by observation. Now, you may say, well, couldn't I just put the 2 in for the x and do 2 squared, which is 4, and then I know what the limit is? Well, that will work as long as x is not undefined at that position. By definition, when we say the limit, we're talking about as we get closer and closer to x without actually being that. Let me show you why. Because in the next one that we're going to look at, we're going to go the limit as x approaches 0 of 5x plus x squared over x. Now, in this case, you can't just take the 0. Now, first of all, because it's a limit, you can't just put the 0 in, because, well, if you put 0 in, you're going to end up getting 0 over 0. Now, that doesn't tell you what the function, the value of the function is approaching as we get closer and closer to 0 for x. You may say, well, yeah, but that's going to be asymptote mit water, because I know when I divide by a 0, it's going to go woo up to this and woo down to that. Well, that's not actually the case. All right, so what... Something's funny. Anyway, so we're going to go ahead and look at a graph. This is the graph of 5x plus x squared over x, which is what I was trying to do there. And you notice it's actually a straight line. Now, it looks like it exists here at 0, but we know it can't, because if I put 0 in, I'm going to get an undefined. So it actually can't exist here. However, it does exist everywhere else, and it's not an asymptote. Let me show you why. If I go into this, and I say, well, let's do this. We're going to factor out the x, so 5 plus x over x, and then I cancel those out. If x were anything except for 0, you could do that. You could factor out the x and cancel them out, which would leave you with the limit as x approaches 0 of 5 plus x. Now, if I put the 0 in, or something really, really close to 0, I note that I'm going to be getting closer and closer to 5. As the value of x gets closer and closer to 0, 0.1, 0.001, 0.0001, I'm going to be getting values here that are closer and closer to 5. So, therefore, the limit as x approaches 0 of 5x plus x squared over x is going to be 5. Now, that is, of course, given that x does not equal 0. So that's why it's so important that we recognize that we can't just put this number in. If it doesn't cause an issue like the 0 did on the bottom, then it would be okay to plug it in. However, keep in mind that limit means that we're approaching from the right, from the left, that x value until we get closer and closer to that center point, right? So the other thing to recognize is the idea that with this one, if x is a little bit bigger than 0 or x is a little bit less than 0, I'm approaching the same value both times, right? I approach 5 from the right, I approach 5 from the left, which is easily seen here. See, I'm approaching as I come from the left, I approach 5. As I come from the right, I approach 5. That means that it converges. Now, that's not always the case. If it is an asymptote, like what we were talking about before, obviously it's going to diverge. One's going to go up to positive infinity, one's going to go down to negative infinity. And so in those cases, we're going to have what we call something that diverges. Now, I'll show you a couple of examples and when each of those occur, either later in this video or in the next one. Now, the basic idea, of course, being that we can simplify this and work through it to find out where the asymptotes are. Or not the asymptote, sorry, the discontinuity. This is, since it can't be 5 at 0, we actually say this is a hole or a discontinuity. Okay, and we'll be doing a little bit more of that later, but for now, that's what we've got. All right, so let me just show you a couple more things. I want to introduce you as well to the rules dealing with logarithms. So here we go. Logarithms. Sorry, I'm doing logarithms with my SL1. So with limits, okay? The limit as x approaches the number of a constant is a constant. Now that should make sense. If you say limit as x approaches 0, for example, limit as x approaches 3 of 5, well, it doesn't really matter what x is. The limit is going to be 5 because this 5 is not affected by the fact that x equals 3. All right, the next one is if I have a constant multiplied by a function, you can pull the constant out front of the limit. The next one is addition or subtraction will turn into the limit of the first function plus or minus the limit of the second function. Then we've got multiplication turns into multiplication of the limits, and of course division turns into division of the limits. Again, assuming that the limit is not 0. If the limit is 0, then we're going to have to do something else similar to what we did up above. If the limit is 0, that means we've either got an asymptote, which means that it diverges, or we've got a hole, in which case we'll be able to do what we did up above. And we'll talk about that in a little bit more detail. So let's just look at a couple of examples using these rules. Okay? So let's take the example of the limit of x plus 3 times x minus 4, and let's just do the limit as x approaches 2. All right? So now you could just kind of figure this out already, but we're going to go ahead and look at this from the perspective of let's learn how to use the limit rules. So I've got two things being multiplied here, so I can rewrite this as the limit as x approaches 2 of x plus 3 times the limit as x approaches 2 of x minus 4. And then, of course, I've got an addition here, so I can rewrite it as the limit as x approaches 2 of x plus the limit as x approaches 2 of 3. And that will all be multiplied by the limit as x approaches 2 of x minus the limit as x approaches 2 of 4. Okay, and so now it's as simple as it can get. You may say, well, I didn't really need to do that, Mr. Bauer. And I say, yes, I understand that, but I still want you to get used to the way that the limit rules work, because they are going to be helpful and useful later on in much more complicated situations. So the limit as x approaches 2 of x, well, obviously if x is getting closer and closer to 2, then if it's just x, then this is going to be 2. The limit of a constant we learned up above was that constant.
Dad,
And then multiplied by, oh, hold on. We found a mysterious mop. Okay, anyway, back at it. Okay, limit as x approaches 2 of x. Obviously, if x is approaching 2, that will be 2. And then minus 4, because the limit of a constant is that constant. So 2 plus 3 is 5, times 2 minus 4 is negative 2, which means that the limit will be negative 10. All right, so there's an example, and let's go ahead and do one more since we got just a minute. Actually, why don't you try this one on your own? I will put the answer right here below. Please try to do this on your own before checking the answer. Please try to show all of the work, all of the steps to show each of the limit rules in use. All right, I'm going to pause it, you pause it, work it out, and we'll see what you get. All right, hopefully this is what you got. Hopefully you got -3, so we would say the limit as x approaches 1 of this function is -3, and we would actually say that it converges to -3. We would say it converges because since we use the rules throughout, and since for each one of these y approaches the same thing when you go from the left and from the right, that means that in each situation you're going to get exactly the same thing, regardless of whether you're going to one from the left or from the right. Okay, so we would say that it converges. That is, converges, not converses. So converges to -3. All right, so there's your first video. Watch the second one for a little bit more on limits and asymptotes.